Hello everyone. Now we are going to learn about the binary code. So what are the binary code and how do we determine them? Well, first of all, we determine the binary code as weighted binary or weighted code you may say and non-weighted binary or non-weighted code. So these are the two categories that we are going to learn. So let's first learn about the weighted binary. So in the weighted binary, it simply means the number. Well, which kind of number we are talking about here? Well, let me tell you. Weighted binary codes are those codes which obeys the positional weighting principles. Positional weighting principle. So, what we mean here? Let's understand that. Weighted binary having the positions based upon that. 8421 or BCD, 2421, 5211, reflexive, and sequential. These are the categories of the weighted binary. Well, so how we determine that? Well, in the weighted binary code, these codes which obey the positional weighting principles, each position of the number represent a specific weight. To elaborate that, let's understand it with an example. Like, assume that we have 3 bits. So, here we do have 2 to the power 0, here we have 2 to the power 1, and here we have 2 to the power 2. That we have already done, right? So, this ascending order flow is known as weighted binary. So, what is non-weighted binary that we have seen here? Well, non-weighted binary simply means they do not follow such codes. Like for example, we can have 2 to the power 0 here, 2 to the power 1 here and 2 to the power 2 here. Means 4, 1, 2. And in this case we have 1, 2 and 4. So this is a regular order that is known as weighted binary. It is also weighted or numbered in magnitude. Like we have number 2, number 1 and number 4. But this is not ordered. So in one word we can say weighted binary are ordered weights, and non-weighted binary are unordered weights. So these are the fundamentals that we need to learn. Now let's proceed to the thing that we have started in the weighted binary form. So in the weighted binary form, we are going to learn all these things. So to understand it one after another, let's start with the first one, which is 8421 or BCD. Well, BCD simply means binary coded to decimal. You may say to remember it. Okay, so let's make a table to understand this more clearly. First of all, let's make decimal that we are familiar with, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, exactly. 8, 4, 2, 1. And then let's take 2, 4, 2, 1. And then 5, 2, 1, 1. And finally, axis 3. So, why all these categories are here? Well, as you can see, these are the categories that we have noted down here. Well, you are not able to see the sequential and reflexive one. These are the same as sequential and reflexive one. So, I will tell you one after another. Let's understand these terminologies first so that we can learn it quite deeply and understand its significance. Okay. So let's draw a few vertical lines. Okay, now we are ready. So let's take it like this. Let's start with the numbers with 0, 1, 2, 3, 4, 5, 6, 7, 8, and finally 9. So this is the number in decimal number system. Now let's code it first in 8421. Remember, the 8421 means simply 4 places in which we have 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. We have already discussed the similar scenario that we are going to apply right here. So for 0, we are going to write 0, 0, 0, 0. And for the 1, we are going to write 0, 0, 0, 1. Means this is on. 1 is on. Okay, for 2, we are going to write 0, 0, 1, 0. Now for the 3, we are going to write 0, 0, 1, 1. Now for the 4, we are going to write 0, 1, 0, 0. Well, if you notice the pattern is very obvious and simple. 8421. So with the help of these numbers 8421, as you can see on the top right here, is actually presenting the offs and on in the form of zeros and one, in which we are converting the numbers in the decimal form, in the definite decimal forms. So this is the way of doing so. So let's complete this. 0, 1, 0, 1. Now if you count it down, so this one at this place is representing 4, and in this place it is representing 1. So 4 plus 1 is 5. Now for the 6 we need 0, 1, 1, 0. For the 7 we need 0, 1, 1, 1. For 8 we need 1, 0, 0, 0. And finally for the 9 we require 1, 0, 0, 1. So these are all the numbers in BCD or 8421 coded form. So we have just coded these numbers, and now we are able to convert decimal number into a binary form, a weighted binary form of 8421. So we are done with our first category, which is 8421. Now let's proceed to the second category that is waiting for us. Now, for 2421, if you count it down, this is representing 2 plus 4 is 6, 6 plus 2 is 8, and 8 plus 1 is 9. So it is somehow representing the decimal itself. So this one is written as 0, 0, 0, 0. Because for the 0, everything needs to be off. That by default means 0. Now for the 1, we need to write 0, 0, 0, 1. Till this point, it seems quite similar to the 8421 form. Now, let's write for the 3. So, for the 3, we need to write here 0, 0, 1, and 0. For the 3, we need to write 0, 0, 1, 1. Till this point, you can see it represents quite pretty much very much the same as 8421 pattern of the coding. And which form of the coding we are talking about, we will learn that in just a moment. Let's finish this table first. So now for the next one we need 4. So we need to do 0, 1, 0, 0. I hope you are getting the pattern. If you have any problem in the pattern visualization of this that we are making, so you may watch the BCD lecture that we have discussed in earlier video, and we are doing the coding so that our machine, which only knows the zeros and ones, can understand that what we are saying. So one form is the zeros and ones form, that is a division basis. Other forms are made to make a better coding possible and a different variety and diversity either. As according to our needs, we can use that. Okay, let's finish 2421 first. Now we need to code 5. So to code 5, we need to write 0, 1, 0, 1. Now to code 6, we need to write, well, here the thing starts changing. You have two options for this. Either you can have 1 1 0 0, or you can also possibly have, um, in this place we can also have 0 1 1 0. So for easy sake, let's remove this one and let's proceed with this one, and then I will tell you why we have left the second possibility. Now for the 7 we need to write 1101, and then for the next one we were going to write 1110, and finally everything is on to represent the 1. Now the matter of the fact is we are proceeding in ascending order. As you can see, there are 4 zeros in the first place, and in the second place this is just 1, this is just 2, this is just 3, this is just 4, this is just 5. So till this point these two are actually the same, there is no difference in that, but from here it became different, and here we have one more possibility, and that's why we choose 2421 as a different form of the possibility. Like for example, if you are going from one place to another, from like let's say A to B, you are moving, so there is one way like this is quite straight, but there can also be other ways in the real world by which you can reach the B point by traveling from C and then all the way towards B. That depends upon the conditions sometimes. Like you send two photographs, so it sends very quickly these days. Now imagine that with the same color, same place photographs, if you try to send so many photographs as per the capacity overloads. So this process is known as overloading, that we are going to discuss in great detail in coming section. But for now, the overloading thing that you are sending, like there are 50 shades of red which is required by the system to represent that zeros and ones code. So 50 places all are calling the processor that I want the code for the red color, and everyone wants that at the very same time, so it becomes very difficult for processor to decide that which it has to give and which it don't have to give, and there the efficiency and speed comes in a great role. Like these days you don't even feel like, and it sends to every of them, every photograph with the red patches on them or color on them, they appear instantaneously, but it has to do the great timing. So it teaches us the timing that it has made and schedule according to which it lagged and leaded in the nanoseconds and sometimes even microseconds, even smaller amount of the time that it distribute the color red to every possible picture. This is the way where these codings take different path if one path is already busy. Like for example, there are two photographs which require the number 5 for any specific purpose to deliver. Now, one is 0101, but another system also require the number 5, so a processor can decide to code it differently or can give us differently. So this is just a very small glimpse to just understand the scenario that what's actually happening inside the system. So I think this is the great possibility if we learn more than one ways to code the decimal into the binary system. It is like you have learned the English language, and now if your native language is something like Chinese, So you can convert that English to Chinese. If your language is Mandarin, you can convert that into Mandarin. If your language is Japanese, you can convert it into Japanese. If your language is, let's say, Hindi, so you can convert all the English language into Hindi language. So this gives a variety and the possibility. This is the extension of digital electronics, and there the complete things starts changing in its own self. Okay, I guess you get the idea of it. But for now, let me also tell you that if you have not get it completely, that's completely okay, because my focus in this section is just to teach you the mathematical stuff, the Boolean algebra, as the section is named itself. So we are trying to focus on that part and not on the behind the scenes part, that how its applications are actually working. So don't worry about that, we are going to learn everything in a great detail, but in the coming sections. For now, as you will not feel like alien in this environment of the maths which we are learning in the form of the Boolean algebra or the coding systems, I just told you that why these things are have been doing, why we are doing these all the things. Okay, so let's finish up this all the things and let's code 5 to 1 1 now. So 5 to 1 1 is 0 0 0 0, as we see, and the second one is 0 0 0 1. Now to write the 3 we need to do 0. Can you guess? Okay, we need to write 2, so we can do it in two ways again. We can do it like 0 1 1, or we can do it like 0 0 1 0 0. These both represent the number 2 according to this code. But we are going to choose the format which is 0 0 1 1. Now the next format we require 3, so we are going to write 0 1 0 1. Now the next one we require 4, so we are going to write 0 1 1 1. See the pattern of it. We are trying to maintain the pattern by which we are always going in ascending order, means increasing order. We can also go in the random orders, but that will not called as weighted binary. That will known as the non-weighted binary. So we are trying to protect ourselves from that. That's it, nothing else. So for writing 5, we can write 1 0 0 0. For writing 6, we can write 1 0 1 1. For writing 7, we can write 1. Okay, uh, here it will 0. Yeah, 0 1 1. Now for the 8, we have to write 1 1 0 1. And for the 9, finally we have all our ones. I hope you have got the glimpse of it. You can also write it down so that you can practice that for your own self as in the form of the coding. And let me tell you something very interesting. This is the number that we have just learned, 5 to 1 1. The sum is also 9, right? 5 plus 2 is 7. 7 plus 2 is 9. So it is decimal form itself. Now we are just left with the last form, which is excess 3. So what is the meaning of excess 3? Well, this is kind of the interesting thing that we are going to have. So in excess 3, we actually exceed the three numbers. Like, let me write it first and then try to guess it down as I am writing these all the things, so that we will learn the things in a great possible way. Okay, so let's begin. So For the number 0, we are going to write 0, 0, 1, 1. Next one is 0, 1, 0, 0. The further next is 0, 1, 0, 1. Further next is 0, 1, 1, 0. The further next is 0, 1, 1, 1. Then 1000, you can say, well, 1 triple 0. 1 double 0, 1. Then 1, 1, 0, 1, 0. Then finally we have 1, 0, 1, 1. And in the last we have 1, 1, 0, 0. Well, these do not seems like I have not written which kind of the code we are following here. It's just written access 3. Access 3 means 3 ahead, like 1, 2, 3. 3 ahead. So the first number is this one. Then 3 ahead. So to write the number 1, we need to get 3 ahead. 1, 2, 3. So we are writing 0, 1, 1. I hope you are able to notice that. Let me change the color so that we can see the things quite clearly. And let's remove few of the things. Yeah. Now, when we needed to write 0, we wrote 1, 2, 3. Axis of 3. We choose this number. Okay. And when we needed to write the number 1, we chose 1, 2, 3, which is the fourth number, 0, 1, double 0, as you can see here. And now when we needed to write number 2, we are going to again go access 3. So this is 0, 1, 0, 1. I hope you get the idea what is the meaning of access 3. Just like plus 3 it means, and you just have to plus add 3 and start from there. Every time you need to write a number, just add 3 and then write it down. So this is the access 3. So now you got the mastery of the weighted binary system, and you can write it down in any of the possible form and can understand that how the machine is actually doing it, how the work is actually going to happen. With these all the things, let's learn about the reflexive and sequential code. So what is reflexive code? Hmm. Can you guess by its name that what it means? It's pondering time, my dear friends. So let's ponder upon that. So let's go. Okay, so the matter of the fact is reflexive means something that reflect. A code is said to be reflexive when the code for the 9 is complement for the code of 0. Complement of code 9 is complement of code 0. Well, I hope now you are getting the point that why we have learned the complement first. Because to learn the coding way, we need to learn the complement first. So we have already learned the complement. Now complement of 9 is complement of 0. So in the same way, complement of 8 is the complement of 1. Complement of 7 is complement of 2. Complement of 6 is complement of 3. Complement of 5 is complement of 4. And the sequence is completed. And vice versa we have here. So these are the complements of the reflexive in nature. Like in science, reflection means if you are standing in front of a mirror, you are able to see your own self. That is called as reflection. So by using the principle of the complement, we are reflecting the code. So with less numbers, we can do more operations. And this is the logic behind this. With the less number of operation, I can do more things. I can write 5 and 4 just by pressing one number and putting a definite logic that which way it has to go, here or here. So I can just use the 5 numbers and can get 5 more numbers in the binary form. Well, When we are seeing it in the decimal form, we are not getting that why it's so unique or different, or why even it's going to be get used. But the key point here is that the numbers we do have, like for the 0 we write 0000, and for the number 9 we write 1111 in most of the coding forms. So these both have same complement or the complement of each other. Once you feed that, it becomes easy for machine. It just has to choose the way. It is something like we started developing the memory in the machine, and that gets possible by reflexive coding. I hope you have understood the reflexive coding now. And now let's proceed to the last coding, which is sequential coding. So sequential coding, as its name suggests, it is a way to make the things in sequence form. So a code is said to be sequential when two subsequent codes seen as a number in binary representation differ by 1. The great 8 mathematical manipulation data, the 8421 and XS3 codes are sequential. Well, in short and simple, 8421 and XS3 that we have already studied here. Let me show you here. So 8421 and what's the next one? XS3. Absolutely. These are the sequential code. These are working in a sequence, in a manner. So what other codes are working that we are not calling it manner and all that things? Let me show you that example. In the reflexive coding, the code can be 2421 type coding, 2421 and 5211. So this is the reflexive coding. So we have already studied the reflexive coding, which is 2421 and 5211. And we already studied the 8421 and XS3 coding, which is known as sequential coding. It is in a sequence, and this is not in a sequence. Not in a sequence means 2421. If you observe it closely, the 4 is the highest number, and then the 2 came. 1 came, 2 came, and then directly 5 came. So these are not the sequence. These are made to understand the reflexive nature of it. Like here, if we notice it down, so we get the complement of each other and the reflexive nature. So this is how the entire system of weighted binary numbers are actually working. So we have studied all these systems. So the first system, that 8421 is known as sequential code, is also known as sequential code. 2421 and 5211 combinedly they are called as reflexive coding. And the sequential code is itself is this one, and we have missed one name here, which is in the sequential form we have XS3. XS3 code also comes in the sequential coding. Well, I hope you have understood the binary, weighted binary in a great detail now. And in the next one, we are going to understand that what's the non-weighted binary codes, and that will lead us to the 90% completion of this section. So stay tuned, God bless, and see you in the next one.